Problem 3. Problem 3. Let me call it A. So we want to solve the integral of ln natural log x 3 dx. Natural log x 3 dx. So how do you solve this problem? Okay, so yes, we are going to solve it correctly by integration by part. So how do we then, now how do we use that? Okay, are we getting that? So we are having this problem and that we use the integral of, let's say, ln x dot 1 dx, right? Is that what you suggest? Okay, yes, that's correct. So how do we solve this problem? You use your integration by parts. You remember uv minus what? Maybe v du. Let's say integral of u dv equals this. So using this, I can just say, let's say this is u, let's say this is the v. So this means that, so I'm having my u to be what? U to be natural log x raised power 3. My dv equals 1 dx. You remember? Yes, but remember this is the formula. So I'm just taking the time to explain each one of them. Now, you need to obtain the u with respect to x. So this will be what? 3 over x ln x squared. Exactly. You remember? You can use your u substitution method to solve this problem. Then you will get 3u squared. 3u squared. Then you need to differentiate u, which is ln x, which is 1 over x. Yeah. And then I take my v. My v is should be what? X. So this equals uv, my u, ln x3 minus the integral of v, x, the u multiplies 3 over x ln x squared dx. Right. This gives x ln x raised power 3. This cancels this one. Negative 3 integral of ln x squared dx. So you need to integrate this one again using the same process we did use. If you use it correctly, your final answer should be ln x raised power 3 minus 3x ln x squared plus 6x ln x negative 6x plus c. So that's if you solve, just as we solved for natural log x raised power 3, so also you solve for natural log x raised power 2. Using the same procedure, you will arrive at this problem or this solution. Sorry. Look at the B. You are asked to integrate x sine x dx. How do you solve this problem? Let's try to look at it together. You remember this will be, this is x sine x dx. So this gives me, so let me use, let's say I have my u, okay, let me use the same approach that I use here. So I have u to be, let's say u is x, and or the v, it depends on what you want to use, dx. So I can say u dv is equals to uv negative v du. So what is u? This is x. What is the v? If you integrate this should give you negative cos x. Then this one, if you differentiate, this should give you du dx. And so uv, x multiplied by, so this will be negative cosine x. Then minus integral of what is our v? Our v is negative cos x. And what is our du? Our du is dx. And so you should have negative x cosine x, positive cosine x dx. And this should give you negative x cosine x plus sine x plus c. You see? Problem 4. Let's see. This is A. You're asked to integrate x over square root of 9 minus x squared dx. So how do we solve this problem? So this is more of like the inverse trig, something like that, but it's not every time you should use trig if there is a simpler way to solve the problem. So how do you think we should do this problem? How do you think we should solve this? By use substitution, let 9 minus x squared equals to u. So that I have the u equals to negative 2x dx. Now, so this means that the x is simply equal to negative du over 2x. And so you have x over the square root of u multiplied by negative du over 2x. This cancels out this one. So this means I have negative 1 over 2 integral of u negative half du. So if you solve this problem, you should have negative square root of u plus c, and that will give you negative square root of 9 minus x squared plus c.